Hello everyone and welcome to Mark Scheme Merchant. This video will be a quick overview of electrophilic addition. This topic is a goldmine for banking marks in the exam. Okay, let's dive into the topic. Electrophilic addition happens when electrophiles react with the alkene groups of a molecule. First off, a must-know definition. Electrophiles are electron pair acceptors. The carbon-carbon double bond has a high electron density because of the pi bond, which makes it the perfect target for something electron deficient, which is our electrophile. Let's explore this with an example. I'm going to use propene as my alkene and hydrogen bromide as my electrophile. HBr acts as an electrophile because the hydrogen is slightly electron deficient, making it slightly positive. We represent this by showing it as delta positive. The bromine is delta negative. The electrons from the pi bond attack our delta positive hydrogen. The bond between the hydrogen and the bromine breaks heterolytically, so both electrons from the covalent bond are transferred to the bromine. The hydrogen attaches to the carbon with the most hydrogens already attached to it, more on this later. This creates a carbocation intermediate, the middle stage of our electrophilic addition. We have a positive charge on this carbon, forming a carbocation, because this carbon only has 3 bonds rather than the usual 4. Since the electrons from the hydrogen-bromine bond have gone to the bromine, it has now become a nucleophile. It needs to get rid of all the extra electrons it has. You must show lone pairs on your electrophiles and the negative charge as well, otherwise you will lose marks in the exam. Next, our nucleophile will add on to the carbocation. You show the curly arrow moving from the lone pair to the carbon. Finally, show the final structure. And we have formed 2-bromopropane. This takes us on to Markovnikov's rule for unsymmetrical alkenes. Carbocations are positive and unstable. To make them more stable, alkyl groups push their negative electron density to the positive carbon. The more alkyl groups you have, giving their electron density, the more stable the carbocation becomes. So from least to most stable, you've got primary carbocation with 1 R group attached, secondary carbocation with 2 R groups attached, and tertiary carbocation with 3 R groups attached. With propene, we could have had a primary carbocation or a secondary carbocation like the one I showed before. The more stable intermediate will go on to form the major product, which will be the most abundant, so the major product in our example will be 2-bromopropane, and the minor product will be 1-bromopropane. If you'd like me to cover more topics in this format, let me know down in the comments. Hopefully this video was helpful. If it was, give it a like, subscribe so you don't miss any upcoming videos, and send this to your peers to help them out.